Welcome to March 24th LeetCode Challenge. Votes to save people. You're given an array of people where people at index I is the weight of the ith person and an infinite number of votes, where each vote can carry a maximum weight of limit. Each vote carries at most two people at the same time. Provide the sum of the weight those people is at most limit. Return the minimum number of votes to carry every given person. So this is quite a heavy math one related. So let's see, we have example number one here, given the array of integer people, we have a limit of 3. So how many, or what's the minimum number of people we can carry on a boat? Every given person. Well, we need one boat because we have the weight of one person being 1, the second weight of the second person being 2, 2 plus 1 equals 3, therefore it is equal to limit, and that's okay to be in a boat, one boat I should say. How about this? Example number 2, we're given a limit of 3, and we're given an array of people here. How many boats do we need to to save people? Well, the answer is 3, because we have 3 boats, one for the array, one person weighing 1, one person weighing 2, right? That's filled out one boat. We have another one for 3. Since the limit is 3, then that means that we have to take a whole boat for this one person. And the last remaining is 2, therefore we need 3 boats. Alright, we have a limit of 5 here, and we have this many people. So we see how each value is more than the sum of being less than 5, so therefore we need 4 boats, 1 boat for each person. Alright, here are constraints. The length of people, the rate people is between 1 to 5 times 10 to the 4. Each index of the people is between 1 to between the limit, and which is the 3 times 10 to the 4. So this is a good thing to know. We know that each individual person's weight is less than or equal to the limit, so that's good. So there's nobody heavier than the limit. Alright, so in order to solve this, I'm starting to think of a little bit of a greedy approach algorithm here. So if the heaviest person can share a boat with the lightest person, then we should do that, right? Because if the heaviest person being 2, and we share it with one person, the lightest person, then if we could do that, let's do it. Otherwise, the heaviest person can't pair with anybody, so then they get their own boat, such as these guys, right? They each get their own boat. So this rationale works because the lightest person can pair up with anybody. They might as well be paired with the heaviest person, right? If that can work, then put them on a boat. So to do this, we're going to create an algorithm that's kind of using 2 pointers as well. And we're going to let people at index I here be the weight of the ith person, but also it's currently the lightest person. If it is currently the lightest person, then we're going to put it with the heaviest person, right? Being people at index j. So let's say that we have an I and a j, 2 pointers, so we're going to find the heaviest and the lightest person. Then we're basically put them together if we can, and if the heaviest person can share a boat with the lightest person, that means that if people at index I plus the people at index j, right, where I being the lightest and j being the heaviest, is less than or equal to the limit, as mentioned here, then we're going to do so, and then otherwise the heaviest person sits on their own boat. And that's pretty much it. So I was going to use the greedy / 2-point algorithm together, and first thing we need to do is a good idea would be to sort the list first. Sort the people lists. Sort. And then next thing we're going to do is define I and j, which are 2 pointers, and they are going to be the heaviest and the lightest. So the index at index 0, and then we're going to probably find the last index as well, so the length of people minus I, minus 1. So once we sort the list of people, that means that the first index is the lightest and the last index is the heaviest. And then we're going to have an output, which is going to keep track of our count of the minimum number of boats we need. And I'm going to actually call it boat. Boat. And that's going to be 0. So we're going to form a while loop here. So while the lightest person I, index I, or the index, I should say, of the lightest person is less than the index of the heaviest person, then we're going to keep on, it could be equal to Didn't think about that. So if that happens, that means that we compare them together. Therefore, we should increment our boat by 1. Once we have incremented our boat by 1, we need to check if the limit works or not, right? So the limit of the boat. So if the people at index I plus the people at index j, being the heaviest, is less than or equal to the limit, then we could basically change, that means that we incremented our boat size, I should say, and then we should move the index I to the next person, next heaviest person, or the next lightest, well, the person that's next to the lightest person, to the right. And to do that, we just increment I, the pointer number 1, I by 1, and then we also need to decrement j as well, which is the pointer for the heaviest person, going to the left. And then we keep like returning, continuing this algorithm, and then until we could add boats together, and then that's pretty much the algorithm, right? And then we want to return our number of boats. Return boat. Hopefully this should work. Alright, looks kind of reasonable, and so it's kind of using the greedy approach with the 2 pointers being I and j. Awesome, accepted. Time complexity, it's runtime complexity, I should say, is big O of n log n due to the sorting algorithm, or also at the same time, log sorting algorithm is log n, but also we have the length n is the length of people, right, from the sort algorithm. We have space complexity being big O of n, where n is just the count of a variable an integer, so therefore big O of n, which is the number of boats. There you go. Have a good day, guys.